Amar, why late?
Sir, iPad was switch off.
My God, so much. Okay. Okay, so we will start the class. So where were we? What we were doing?
We were doing maths.
Life process. Life process, no?
Uh,
So Kritika, how was your exam? Was it good?
was easy, sir.
It was easy. So what I taught, everything that like it came from that side.
Yes, sir, everything clear. But in one question, it was of 3 marks. It says
Hmm.
that 5x in a quadratic equation. It says 5x. I got confused and I thought it might be a wrong question, but it was actually 5x squared. And because
Okay, okay.
5x 2, I made all that.
So it was printing mistake.
Yes, sir. And because of that, my one question got.
So tell teacher that sir, this is printing mistake. How will we will do?
Yes.
When Amar was in offline, he used to fight with me. What is this? Okay. Okay. So we will start our thing. I want to do first the electricity chapter because the last part is left for this. Okay, so we'll complete that electricity last part, then we'll go to life process, and from tomorrow we will start our maths and science like both regular interval time. Okay, have you got this? So take out the chapter electricity. Okay. So we learn about the Joule's law. What is the Joule's law? H square is equals to I. So H is equals to I square RT. Yes or no? Yes or no?
what
We
heat?
learn about this. So okay. So now remember this thing, guys. So the heat energy, okay, heat energy is also like it is same as the electrical energy. It is same as electrical energy. Now, what does this mean? This means that like you are getting electric bill in your house. Okay, 200,000, 2,000, 4,000, like this. So how this electric energy bill is created? So the formula of this is E is equals to I square RT. What does this mean? I square RT. Okay. So same like H is equals to I square RT. No? Same I E is equals to I square RT. But the problem in this is whatever the answer you will get, it will be in the watt hour. It should be in the watt hour. Okay, so basically we'll try to do some question based on this. Okay, just for now, just understand it like this that E can also be calculated with I square RT. What is the formula for the E? Okay, are you getting this?
Yes, sir.
Yeah. Yeah. So now put a heading electric power. Put a heading electric power. Electric power. Now, electric power is basically, you can understand that a bulb, if you will put into the fuse, how much power it will take, it's depend upon the how much current it will use. If that bulb will take lots of current, it means that it will have lots of power. Yes, like geyser. Geyser takes lots of power, means it use lots of current. Mobile charger. Mobile charger doesn't take lots of power, means less current will go inside of it. So, if a substance or if a device takes lots of current, means the lots of power is needed. If device take not so current, then less power will be needed. So, electric power is defined as V into I, in
So
which,
P means power.
yeah, P means power. P means power. I means current. V means voltage. V means voltage. Power, current, and voltage. Okay. P is equals to V into I, which is power, voltage, and current. Okay. Now remember this thing, that power unit is watt. So Amar, what is the unit of power?
Watt.
Yeah, that's why I'm asking. What is the unit of power?
WATT watt.
Yeah, what? What is the unit of power?
WATT.
Yeah. Okay. Chalak, bro. Okay. So, what is the unit of power? It's watt. Okay. Now, remember this thing. Power. Sometimes these types of questions are also there, that these two bulbs of this and this power is connected in a series, or they are connected in a parallel form. So, like for example, if I will take two bulbs, and as you can see, they are connected in series. Yes. So if they are connected in series, so the power consumption will based on this. Like we have this formula, P is equals to V into I, and we know that in series, the I is same. It's constant. Okay. So instead of V, can I write IR like this? Because I is constant, no? In series, we learn that the current doesn't change because there is the same path we are using. So, so we can use that P is equals to IR into I. So P is equals to
I square.
I square R. So when two bulbs are connected in series, then we have to use this form. P is equals to I square R.
Sir, if voltage is given in the question, so then we can simply V into I.
Yeah, but it will given it like this, that calculate the current if two bulbs of 100 watt and 20 ohm resistance. Are you getting this?
If two bulbs are 100,
100 ohm and 20 ohm resistance. This is the first bulb, and the second bulb is 200 ohm and 30 ohm resistance. Then in this case, we have to use this formula to get the value of I. I'll tell you. I'll tell you how.
okay.
Okay. And if two bulbs are arranged in parallel, if two bulbs are arranged in parallel, then in this case, what is constant? In parallel, what is constant? Can you tell me?
I.
Bah.
V.
Yeah. So we have the formula V is equals to IR. I is not constant, so can I write I is equals to V upon R?
Yes.
So P is equals to V into I. P is equals to V into V upon R. So P is equals to V square by R. So if they are arranged in parallel, then we have to use this form.
Okay.
Are you getting this, Kritika?
So we have to write.
Yes, sir.
Okay. Write it down quickly. I'll give one question.
Sir, I have a doubt in chemistry.
Yeah. What doubt you have?
Sir, why we rub the magnesium ribbon before burning?
So that the impurities and the oxides which are formed on the magnesium ribbon can be removed by rubbing it.
Sir, the oxide formula is MgO.
Yeah. So oxygen is already there in the atmosphere, na?
Yes.
That oxygen will like it will react with magnesium, make the oxide layer of magnesium, which will become the hindrance by while burning in the while burning with the fire.
Magnesium ribbon. So, sir, after burning, we get the magnesium oxide only.
After burning,
We get the magnesium oxide.
yeah, but the magnesium oxide that is already formed on the magnesium ribbon, if you will not rub it, okay, then what will happen? That will become the hindrance in burning. Okay, so that is why.
So what is hindrance?
Hindrance मतलब कि वो प्रॉब्लम करेंगे जलने में, मतलब अच्छे से जलने नहीं देगा. Okay, write it down. Done? Amar?
Yes.
Yes, sir.
Okay, then write it down. Two lamps rated 100 watt and 220 volt. Two lamps rated 100 watt and 220 volt are and other 60 watt 220 volt 60 watt and 220 volt
The
are
two lamps
connect
rated 100 watt and other 200 watt.
no, yeah 100 watt 220 volt V and
First
other
lamp.
this is the first lamp combination and other is 60 watt
60
and 60
watt.
60 watt
Hmm.
dash 220 volt V
Okay.
are
Fine.
connected in parallel. Are connected in parallel. Okay. What current is drawn from a line? What current is drawn from a line, comma. Find the total resistance also. Find the total resistance also. Find the total resistance also. Now, what is the first thing? What is the first thing they ask?
Find the current.
Find the current. So
Yes.
we have the formula P is equals to VI. Okay.
Hmm.
Now for the first bulb, we have P, which is 100 watt, like power unit is watt.
Yes.
Okay. And V is volt.
Hmm.
V is volt, which is 220 volt. Can I get I from it? P is equals to VI. Can you solve it, guys?
Yes.
Kritika, like we have the P value, we have the V value, you have to find the I. So this is the bulb one. Bulb one current,
I.
which is I1.
The 0.4 first lamp current.
0.4 or 0.45? Solve it fully.
0.45.
Yeah. 0.45. So in the first current, in the first bulb, the I1 is 0.45 ampere.
Sir, what
Now,
is the SI unit of current? Ampere.
yeah, ampere. Okay. Now if I will talk about second bulb. Now second bulb power is how much? 60 watt, and volt is same, which is 220 volt. Now calculate the IT. I2 बता.
Sir, 0.27.
0.27. Yeah. So the I2 is how much? 0.27 ampere. Ritika, are you getting this? So this
Yes,
is
sir.
I1 and this is I2. So what is the total current? It will be I1 plus I2 because they are in parallel. That's why they have different current. Are you getting this? In the
Yes.
question, it is given that they are in parallel. That's why the current will be different. Are you getting this? Say yes or no?
Sir, in the question, it is written, we have to find the total current or divided current.
No, total current. Yes. You know what is the current drawn from a line? We are asking na that thing. What current is drawn from the line?
The total current.
Yeah. So total current will be I is equals to 0.27 plus 0.45. So if you will add it, then you will get 0.72 ampere.
Sir, if it is asked different lines,
Hmm?
different line current.
Different line current means if they will ask that what is the total, what is the current drawn by each bulb, then you have to write like this.
0 point अलग अलग करके.
Ah.
So now the current will remain equal for both the bulbs.
No, why? They won't have because they're in parallel, na? If they are in parallel, so the bulb current will not be same, na? In the first bulb, it is 0.45. In the second bulb, will be 0.27. But the total current, if I will draw the diagram for this, it's gonna be look like this. This is the first bulb. This is the second bulb,
Hmm.
and this is the source current.
Yes.
So this is 220 volt.
Hmm.
Now the current which is flowing from it, it is 0.272 ampere. In the first bulb, which is 100 watt, it is 0.45. And the second bulb, which is 60 watt, it is how much? 0.27. It's gonna be look like.
Okay. Now we have to find the resistance.
Now we have to find the resistance. Total resistance. So first find R1. How will you find the R1? Like in this case, we have V, which is 220 volt.
Hmm.
We have P, which is 100 volt,
Hmm.
100 watt. Can I use this formula? P is equals to V square by R.
Yes. Sir, is it 484?
Yeah. So it will become R is equals to V square by P. Now what is P? Sorry, V. 220 into 220 upon 100. This and this and this and this will cut. So I got R is equals to 484 ohm.
So can we use V equals to IR?
V is equals to IR also we can use. Like we got I, we have V, we can use that also to find the R. So no problem in that. Why I'm using this formula here? Because if they will ask that find the resistance directly, not asking the current, if they will ask that find the resistance, then we can use simply this formula instead of first finding the I and then going for the V is equals to IR. We can directly use this formula. That's why I'm saying this. Got it?
Okay, okay. Yes. Yes.
Yes, sir.
Okay, now we'll do the next question. You guys can do this. Find the R, then one up because they are in parallel. So one upon R1 plus one upon R2. You have to use this. So leave some space and then write another question. Write another question. Okay, before writing down the another question, we will understand. Now we'll come back to this electricity part. Now, electrical. Okay, so we have this formula: I square R T. Yes or no?
Hmm.
Just I told in the starting in the beginning of the class. Now I square R. What I can write? I
I
square R.
square
What I can write?
P.
Are you getting this? Means if I will write E is equals to P into T. P means power, time means how much time it is working. Now listen guys carefully. For example, if a geyser which is 1000 watt, okay, geyser of 1000 watt, like power is mentioned 1000 watt, and if it will take, if it will working for 1 hour, if it is working for 1 hour, so how much electrical energy it will use? So if I will solve it with this, so E is equals to 1000 into 1 hour. If I will write 1 hour, so E is equals to 1000
Is
kWh. No, 1000 WH means watt hour. Are you getting this?
we have to write in water only.
Yeah, watt hour. When we are
Yes.
finding the electrical energy, we need to write in kilowatt hour. This is watt hour only.
Yes.
Now, 1 kilowatt is equals to one upon no, is equals to 1000 watt.
So we can write
So,
kilowatt here.
huh?
E equals to 1 kilowatt.
Yeah. So 1 watt is equals to 1/1000 kilowatt. Hmm? So if I will convert this into kilowatt, so I will get E is equals to one. Oh, so it will be 1000 divided by 1000 kilowatt hour. So E is equals to 1 kWh. Now this 1 kWh, it is basically called as 1 unit. And government charge us with like there's a small amount like in Rajasthan it's 7 rupees per unit. Okay, so this is called as unit 1 kWh.
Sir, in heat energy, we find the time in seconds.
In heat energy the time is seconds and the unit for that is joules per second. Here it is the electrical energy. So first, the electrical energy, the power should be in the kilowatt. You can see this, and the time should be in hour. Simple as that.
Okay.
Power should be in kilowatt, and time should be in hour.
Okay. Okay.
Write it down quickly. Then we'll do some questions.
Sir, if 1000 is kilowatt, why did you write watt?
Where, beta?
Sir, in E equals to 1000 watt-hour.
Oh. Now I convert the 1000 watt into kilowatt by dividing by 1000. So when you want to change a watt into kilowatt, you have to divide it by 1000. Okay.
Yes.
We'll do some questions. Now write it down. An electric refrigerator
And
electric refrigerator rated 500 watt rated 500 watt. Now W, watt is coming. So watt is basically what? Power. So it's 500 is equals to power. Are you getting this? From the unit, we have to decide what is given in the question. So when you are doing these types of question, you have to make it like this. Power is equals to 500 watt. Like this, you have to write. Just by seeing the unit. Okay. Are you getting this, Gitika? Rated 500 operates 6 hours a day. Operates 6 hours a day. What is the cost of energy? What is the cost of energy to operate it in the month of April in the month of April at 4.5 per unit. At 4.5 per unit. At
4.5 rupees per unit.
4.5 rupees per unit. Very good.
Then complete.
Yeah, this is the complete question.
Sir,
So
in
I will do
April
this
there are
question.
how many days?
Very good, beta. You're in 10th class. Do like this January, February, March.
30.
Do like this. 30. So now what is the time? Time is 6 hours
A day.
a day. Okay. Now we have to multiply it by 30 because total hours we have to find it out. Na? Like 6 hours a day into 30. So total hours that fridge work in the month of April.
Yes.
So we will multiply it by 30. So the time taken by the fridge is 1800 hours. 180 hours, sorry. 180 hours. Are you getting this? This is the time taken by the fridge. Now we know the formula, electrical energy formula is power into time. Now power is basically how much? 500 watt into 180 hours. So the answer will be in watt hour. We have to change into kilowatt so that we will divide it by 1000. So this. It will cut. So 18 fives are how much? 90, I guess.
90.
So I will get 90 kilowatt hours. And now what is 90? Like what is a kilowatt hour? Kilowatt hours is also called as 1 unit. Like in your meter, no, electrical meter, 1 unit it will shift. 1 unit, no, like 20, like 2, 4, 3, 2. Then after some time it will become 2, 4, 4, 2. 3, 2, then 3, 3, then 3, 4, 3, 5. Like this, the unit will change. Na? That unit is basically that. Okay, and then if your government is charging how much? Like 90, like total bill. I will write here like this. total bill. So it is 90 kilowatts into 4.5 rupees. If I will solve this, so I will get answer as 405 rupees. So it
Yeah.
means that in the month of April, you will pay the bill of 405 rupees if your government is so merciful and taking only 4.5 rupees per unit. But in Rajasthan, it is 8 rupees or 7.75 something. So means we have to pay 700 for the fridge only. We are using cooler, we are using ACs, we are using that. That's why in Ashana we have good maintenance bill as well as the electrical bill. अभी आशना का मेंटेनेंस बिल कितना हो गया?
8,000
8,000 वो बिला का.
अभी तक चेंज नहीं हुआ,
फ्लैट्स
बात चल रही थी.
नहीं, कुछ नहीं होगा. और फ्लैट का कितना हो गया?
10.
फ्लैट का ज्यादा कैसे होगा? क्या दिमाग लगा रहा है?
अच्छा हाँ, कम कम 7.
6,400 जो पहले 3,900 तक आते थे, 4,800 तक आते थे. Okay, everyone got this? Now write one more question. Write one more question. If a geyser consume, if a geyser consume consume 25 ampere current, or you write 100, sorry 10 ampere current, sorry, instead of 25 write 10
10 ampere.
Yeah,
Okay.
10 ampere current. Pritika, are you there? Can you hear me? Hello, Pritika. Yeah, she's joining again. Just wait for her 2 minutes. Pritika, can you hear me?
So there is a power cut here. Could you please repeat the questions?
Yeah, that's why I didn't say that. Now, write it down. If a geyser consume 10 ampere current, if a geyser consume 10 ampere current, if a geyser consume 10 ampere current in geyser consume 10 ampere current for geyser consume 10 ampere current and having resistance 30 ohm and having resistance 30 ohm, working for 6 hours a day. Working for 4 hours. Work for 4 hours a day. I'll repeat it again. A geyser consume 10 ampere current having 30 ohm resistance and working for 4 hours a day in the month of January. In the month of January, calculate the electrical bill. Calculate the electricity bill if government charge 7 rupees per unit. 7 rupees per unit.
Sir, can you repeat?
From where, beta?
Sir, from last line.
If government charge 7 rupees per unit. If government charge 7 rupees per unit. Now listen, how much current is there? 10 ampere current is there. How much resistance is there? 30 ohm resistance is there. How much time is there? So time is 4 hours a day.
124.
And And in the month of January, so it will become 4 into 31. So it will become 124 hours. So it means that geyser will work 134 hours, 124 hours. Are you getting this? Yes or no?
Yes, sir.
Okay. Now E has a formula which is I square R T also. But remember this thing, you will get the answer in watt hour. When you will solve this, you will get answer in watt hour. You have to divide it by 1000 so that you can get kilowatt hour. Okay.
372 kilowatt.
So E is equals to how much current? 10 ampere current. So it's become 10 square into 30 into 124. Okay. And I will divide it by 1000 also. So that I will get answer in kilowatt hour. Are you getting this, Gitika? Say yes or no?
Sir, we need answer in watts, so why are we calculating in kilowatt?
Because government is charging 7 rupees per unit. And unit is kilowatt hour, not watt
Yes,
hour.
sir.
It's kilowatt hour. That's why we are converting. Okay, so it will become 100 into 30 into 124 divided by 1000. If I will cut this, I will get 2
372.
372. So this much rupees you have to pay for the geyser. Are you getting this?
Sir, 372 kilowatt hour नहीं होगा?
No. Sorry. What are you doing, Amar?
क्या sir?
What are you doing?
372 kilowatt
372? Yeah, it will be kilowatt hour. Are
and
you not able to
rupees we
see
have
this?
to find.
Yeah. The
हाँ,
total bill will be
370 into 7.
372 into 7. So it will become 4
2604.
and then 260.
Yeah.
So this much rupees you have to pay for the geyser.
Sir,
Which
can
is,
you repeat? I didn't hear.
say it again, beta.
Sir, can you please repeat again?
Yeah, so you got it till here? Till
Yes,
here,
sir.
no problem.
I did it.
Yes, sir.
Now they are charging 7 rupees for 1 unit, na? So how much units are there? 372, like kilowatt hour is basically 1 unit, na?
Yes, sir.
So 372 kilowatt means 372 units. And per unit charge is 7 rupees. So I multiplied by 7. I got the answer as 2,604 rupees. So if you will use that geyser, you have to pay 2,604 rupees.
Understood, sir.
Understood? Yeah, I'm a good teacher. That is why you're able to get it.
Yes, sir.
Okay, write it down one question. An electric ion consumes energy. An electric ion consumes energy at a rate of 880 watt. An electric ion consumes energy at a rate of 880 watt.
So what? At the rate of
880 watt.
880.
So watt is there means power.
Power.
Okay.
So
When is at maximum rate? When is at maximum rate? When is at maximum rate? And 340 watt and 340 watt
At minimum.
when heating is at minimum. When heating is at minimum, the voltage is 220 volt. The voltage is 220 volt.
In both cases.
What are in both the cases, maximum or minimum, the voltage is same. What are the current and resistance in each case? What are the current and resistance in each case? What are the
sir,
current and resistance in each case? Yes, beta.
when heating at a minimum,
Minimum rate. Means you know the iron, electric iron, for the pants the heating plate will become more hot, and for the
Yes.
silk like cloth it will become like you have to knob the switch so that the heating will be less. Are you getting this?
Yes, sir.
So that is the meaning of that. Means we have power maximum and power minimum.
The
So
V equals to IR, correct?
yeah, so this is power max, and the power max is 880 watt, and then we have power minimum, and power minimum is 340 watt. We have to calculate the like voltage is common. What is the voltage? 220 volt. We have to find the I and R in both the cases. So in this case also we have to find I and we have to find R, and in this case also we have to find I and we have to find R. Can you solve it by your own, guys?
Yes.
Like when how will you find the I? Like P is equals to V into I. We'll get this I. Then how will you find the R? P is equals to V square by R. We will find this. Are you getting this, Kritika? No. Can you solve it and tell me the answer? No.
Sir, can you please repeat? Voice is breaking.
Can you hear me?
Yes, sir. I can hear you.
Uh, so now we have to find in each case. So how will you find it? We have the formula P is equals to VI. P is equals
Yes.
to VI. Okay. So can you find I from that? And for the R, what formula you will use?
Then
P
we
is
can
equals
use
to
V equals to IR.
V is equals to IR also, and I insist you to use this formula. P is equals to V square by R.
Why?
Use this one also. Because if they will not ask Aina, then you will have no idea how to do it.
Correct.
That's why I'm telling. Are you getting this, Gitika? No. Say yes or no.
Yes, sir.
Where in first case, I got 55 resistance
Hmm.
and I equals to 4.
55 ohm as resistance and I is equals to 4. Correct.
Okay. Where in second case, the I is 1.54 ampere.
1.54 ampere. Correct. Resistance. Ritika will tell. Ritika, Amar is flexing in front of you, getting all the answers. Now you have to tell the answer first. What is the resistance? Amar.
Sir, 142 point something.
Yes. R is equals to 142.85.
Yes.
Now let Kritika join one more time. Then I will tell you one more.
Sir, can you give me a question paper for a balancing of equations?
Yes, yes, I'll do.
Tomorrow is my test.
Yes, sure, sure. Okay, Kritika, are you there? Can you hear me, Kritika? Hello, Kritika.
Sir,
Yes, beta.
sir, can you hear me now?
Yes, I can hear you.
Yes. Sir, it is
So,
about to rain, so my network is so
ah,
slow right
if it is about to raining, please send some rains in Rajasthan also. We are probably. Okay, now listen. So we have this thing, I square RT. Now remember this thing, what I'm trying to say, please pay attention in that, okay? I'm saying that we here in the first case you can see the I is 4 ampere and the resistance is 55 ohm.
Hmm.
And now we have increased the resistance, but the current is decreased. That is according to the Ohm's law. Like if you will increase the resistance, the current will decrease. So from 4A, you can see the chart. From 4A, it become 1.5 ampere.
Yes.
Hmm? From 4A, it become 1.5 ampere. But why? Because why? Because the
Resist
resistance
resistance
because
increased.
because the resistance is
Increased.
increased. Hmm? Now, in this case, if I will check this formula, they can ask you this question. This is very complicated question. Okay, this is very deep question which I'm trying to ask you. That guys, if in this case, if I will increase the resistance, so current will decrease.
Hmm.
But increasing the resistance, why the heat? Why? What is the impact on the heat?
The heat
If
will
I will
also increase.
increase, that's the problem. Ah,
More
see,
resistance, more.
for example, if the current is 2 ampere,
Hmm.
if I will write, I is equals to 2 ampere, hmm, and resistance is equals to 4 ohm in this case. So if I will take out H, so H is equals to 4 into 4 into T. So H will become in this case 16T. Yes or no?
Yes.
Now, now I will increase the resistance. No, yes, I will increase the resistance. So according to this, what is V? V is equals to IR. So it will become V is equals to 8 volt. Yes, according to this. So if I will keeping the V constant, so if the resistance become 2 ohm, if the resistance become 2 ohm, okay, 2 ohm. So what is the I? I will become 4 ampere because V is 8 now. Are you getting this? Now in this case, if I will put, so it will become 16 into 2 into T. H is equals to 32 T. So you reduce the resistance, but still the heat is increasing because more current is coming. You can see that like the 4 ohm resistance was there. Now it become 2 ohm resistance. Can you see this? Hmm?
Yes.
But current is increased to 4 ampere. And what is the formula for the heat? I square RT. It's not IRT. I square means if you will increase the current into the circuit, the square will be there. Are you getting this? Say yes or no.
Yes.
Sir, is I and R 2 and 4 or is it example?
No, it's an example. Like if voltage is 8, so I is 2. Okay, in this question, if I is 2, so what is the resistance? 4 ohm. Yes, it will be 4 ohm because V is equals to IR formula we have, no?
Yes.
Are you getting this,
Yes,
Kritika?
sir.
Hmm?
Yes,
Now
sir.
I change the resistance to 2 ohm. So how much current will go? So V is equals to IR. Now I R is 2 and I is 4 and V I don't know. V is 8.
Great.
So 8 is equals to I into 2. So means I will be 4 ampere if I will reduce the resistance. So I am reducing the resistance like from 4 ohm, the 2 ohm resistance is there. So according to this formula, the resistance, if you will decreasing it, the heat will decrease. But in this case, it is not decreasing. उल्टा ये 2 times और बढ़ गया. क्यों बढ़ा? क्योंकि यहाँ पे करंट इनकमिंग ज्यादा हो गया. Current incoming means it is squaring. I square is there.
Sir,
So
if the formula is
reducing,
IRT, then
then in this case, the
remains same.
heat will remain same.
Okay.
But it is not the truth. The formula is I square RT. It means that keeping the resistance, like if you will decrease the resistance, it not compulsory that heat will also decrease because the current will increase, and when the current will increase, so the heat will increase.
Okay.
Are you getting this? Say yes or no.
Yes.
Sir, could you please repeat the last conclusion?
My conclusion was like if you will reduce the resistance here, like I decrease the resistance from 4 ohm to 2 ohm, it doesn't means the heat will also decrease. Here the heat is 2 times, no?
Yes,
Previous
sir.
one. Hmm? So if you will reduce the resistance, it doesn't means the heat will decrease. Ulta, the 2 ampere current, it's become 4 ampere current, and because of that, the heat is increases by 2 times.
Yes, sir.
Are you getting this? Yes or no?
Yes, sir. Got it.
Got it? So that is why here, even though resistance is increases, like power minimum, you can see the power minimum when the current is increases, not the resistance is like it does not depend. Power minimum or power maximum does not depend on the resistance. It depends on the current. If less current is coming, then only the power minimum will be there. Did you understand? No.
Yes, sir.
Amar, understood? Yes or no?
Yes.
Now, now you guys have a homework. I'll give you a lot of homework. And this terminal exercise is very, very important.
Which exercise?
Okay. Means the last workbook exercise. No, like, we have completed this chapter now. There's nothing is there.
Book exercise.
Yeah, book exercise. like NCRT folder, in text question, everything we have done. You have to do the exercises on page number 221. From page number 221, you have to do till page number 22. All 18 questions.
Sir, please reduce it. I have exam. How will I do?
You have time till Monday, next Monday.
Oh,
So electricity is very
Okay.
big chapter.
Yeah, very, very good question.
Sir, which question number?
Page number 221 and 22. All 18 questions.
Sir, in new book it is 193 and 194.
Yeah. So that part. 18 question it has, no?
Yes.
Congratulations. Okay. Okay, we'll do one more question. We'll do one more question. Which uses, write it down this question. Turn on the camera, please. Okay. Which uses more energy? Which uses more energy? 250-watt TV set in 1 hour, 250-watt TV set in 1 hour, or 1200-watt toaster in 10 minutes. 1200, again
sir,
I'm
can you
repeating
repeat?
it. Which will use more energy? 250-watt TV in 1 hour. Like if you are using 250-watt TV for 1 hour, or 1200-watt toaster, bread toaster in 10 minutes. In 10 minutes. So what is your mute, Amar? You're saying something and just blah, blah,
Time
blah,
is
blah, blah,
in
like this.
time is in second or hour?
In second, like first one, TV set time is 1 hour and the toaster is 10 minutes.
SI unit of time.
So if you are finding the electrical energy, so it should be in the hour, na?
So first one will be in hour.
Yeah, both the things should be in the hour. If 10 minutes is there, you have to convert it into hour.
Mm-hmm.
Gitika didn't understand anything. Gitika asked me, beta,
Sir, I understood, sir.
तो सेकंड वाले का क्या पावर है वॉट
1200 watt.
सर
Hmm.
the first one will use more power more energy
Who? TV?
kV 250 kilowatt hour नहीं watt hour
250 kilowatt watt hour and then toaster?
33.3
Yeah.
correct
You convert it into that, no?
hour 3600 seconds
No, why seconds?
sir you only say मतलब hour
But
मतलब
E2 is equals to P into T.
it's
Now
split
P
even
is
10 minutes
1200 into 110/60, no?
you did that way I did sir 600 seconds upon 3600 seconds
The first one you have divided with the hour, and the second one you are doing with seconds. Why? Both should be hour, na?
sir 3600 seconds equals to 1 hour
Hmm.
10 minutes equal to 600 seconds
Hmm.
600 divided by 3600
Why divided by 3600 then again?
अरे सर आपने क्या करा 10 मिनट डिवाइडेड बाय 60
Hmm.
मैंने भी वही 60 मिनट्स को आप 60 मिनट्स इक्वल टू 3600 सेकेंड्स, 10 मिनट इक्वल टू 600 सेकेंड।
फिर
बस सेम आंसर।
तो तुमने तो 343 बोला, मेरे को तो 200 आ रहा है।
कौन सा?
ये सेकंड वाला टोस्टर का।
टोस्टर का आपका क्या आंसर आया?
200 वॉट आवर।
हैं?
हम्म
1200 इंटू
कृतिका, आपको क्या आंसर आ रहा है?
वेट,
Yes, Kritika. What answer you are getting?
So 200 watt, 1200 watt into 1 by 6 hour equals to 200 watt.
Yeah, 200 watt hour.
Yes, sir,
And
200.
for what for the TV? How much you are getting for the TV?
So 250 watt.
250 watt hour.
Watt hour. Yes, sir.
Hmm. Amar,
6.
okay. If I will ask this question, why are aluminium and copper wires are usually employed for electricity transmission? Why? Why only copper is used in the wire or aluminium wires are used? Why? Any idea?
So because it is less reactive and not that much expensive.
Sir, what's your
Yeah.
question?
The question is why copper and aluminiums are used for electricity transmission.
Better conductor.
Yeah, better conductor means it has less resistivity.
हाँ.
Less resistivity means less resistance, and if less
Hmm.
resistance is there, then
Less.
we can use it for the transmission. Silver has the highest, means lowest resistivity, but we can't use the silver because it's just expensive.
The
Are you
less
getting this?
resistivity will be less heat.
Less resistance, less resistivity means less resistance means less resistivity means less resistance, and less resistance just now we learned. It doesn't mean that it will less. It doesn't mean.
So it is not in the context of heat. We
Yeah,
can't get the answer.
we can't say. Okay. Now, write one more question. An electric heater of resistance 8 ohm. Kritika, turn on the camera, please. An electric heater of resistance 8
8.
ohm
Hmm.
draws 15 ampere for 2 hours.
15 ampere.
Hmm.
Hmm. Fair.
For 2 hours. Calculate the rate at which heat is developed. Calculate the rate at which heat is developed in the heat.
So can you repeat it once again?
An electric heater of resistance 8 ohm draws 15 ampere.
So what?
draws मतलब लेता है.
So can you repeat?
An electric heater of resistance 8 ohm draws 15 ampere for 2 hours. For 2 hours, calculate the rate at which heat is developed. The rate at which the heat is developed. So what you have to find? What is the rate at which the heat is developed? We have to find the power. What do you have to find? We have to find the power.
Sir, in heat energy, we have the SI unit of time is seconds.
In heat energy, the SI unit of time is seconds. Yeah.
So it will be 2 hours means 7,200 seconds.
$7,200.
Seconds.
Yeah. What's the answer, Kritika? Don't confuse with the time. Simple, you can use I square R.
Sir,
We have I.
129640. 9.
First of all, what's the question is saying? The rate at which the heat is done. Means basically they're asking about the power. What is the power? What is the power formula? P is equals to I square R. So we have the I, which is 15 square, and what do we have R? Simple. Even the time is given, there is no use of that. So power is equals to 225 into 8. Power is equals to 1800 watt.
Sir, if we will directly put I square into R into T,
Then what will you get?
15
You will
into
get
15
heat.
into 8 into 7,200.
You will get heat.
Huh.
But what the question is saying? The rate at which the heat.
Rate means.
The rate I told you in the ninth class also. That whenever the rate will come, like rate type terms will come, means you have to divide it by time. So heat you have to divide it by time. Whenever the rate will come, you have to divide by time. So it is I square R T is there, and below T is there. T and T will cut. So what is the remain behind? I square R. And what is I square R? It's power. Simply you have to calculate the power.
Rate equals to.
Did you understand? No,
Yeah.
Kritika. You're Kritika, Amar. Yes. Okay.
Sir, could you please repeat?
Yeah. So basically, they are asking the rate at which you, if you will read the question again, the rate at which the heat is developed. Whenever the this types of rate will come, so it means that you have to divide it by time. Now, what is the formula for the heat? I square RD. This T and this T will cut. What will remain behind? I square R. What is I square R? It's power. Basically, the power we are finding it up. Simply, we will use this formula to get the power. Are you
That,
getting this, Kritika?
yes.
Yes.
Now, write one more question. That is, compare the power. Compare the power. Compare the power. Compare the power.
Compare the power.
Compare the power in 2 ohm resistor. In 2 ohm resistor. In 2 ohm resistor. In each of the following circuit. In each of the following circuit.
In each of the following.
Circuit. So you can take out your page number that book exercise. Can you take out the book exercise? Take out the book exercise. Question number 14 we are doing. We are doing question number 14.
Compare power. Sir, I can't understand the question. Compare the power used in 2 ohm resistor in each of the following circuits.
So in each of the following circuit, first circuit is 6-volt battery with a series of 1 ohm and 2 ohm resistor.
Yes.
So we have two situations and we have to calculate the power of 2 ohm resistor. So first is 6-volt battery. 6-volt battery with 1 ohm and 2 ohm resistor. Okay. So like if I will draw the diagram of it, so it will be around like this is 1 ohm and this is 2. Okay. So if I will calculate the total resistance, what is total resistance? Like because they are in series, so what is the total resistance? It will be 3 ohm, which is
3 ohm.
equals to R1 plus R2. So R1 is 1 ohm plus 2 ohm, so it will become 3 ohm. This is total resistance.
Yes.
Total voltage. What is total voltage?
6 volt.
It is 6 volt. Okay.
Mm.
So we have the formula P is equals to, sorry, my bad. We have, like we have to calculate the I. What is the I in this case? I is equals to V by R.
Yes.
V is 6, R is 3. If I will cut it, you will get 2 ampere current. Now if I will calculate the power, power is equals to V into I. V is equals to, what is V
6,
and what is I?
2.
But because we have to calculate the in 2 ohm resistance, so we will not use this formula. Remember this thing. Now we are changing the formula. We are using this formula. You know why? Because it's particular 2 ohm resistance they have. Now remember this thing. Please pay attention. If I will send this 2 ohm ampere into this, the 2 ohm ampere will 2 ampere current will go in 1 ohm resistor also, and 2 ampere current will go in 2 ohm resistor also. Means in that resistor, how much current is going? In that resistor, how much current is going? 2. And
2.
what is the resistor? 2. So P is equals to 4 into 2. So P is equals to 8 watt. Means this is producing 8 watt power. Are you getting this? Say yes or no?
The 8 watt power who is producing?
This 2 ohm needs 8 watt.
2 ohm resistor is producing 8 watt power.
Using 8 watt power.
Okay. Sir,
Okay.
if it is given in the 1 ohm resistor, compare the power used in 1 ohm resistor.
1
Then we
ohm
have
resistor.
to use the P equals to
Here
2 into 2 into 1.
1. So 4.
Okay.
Okay. Now second part. The second part is that 4-volt battery and 12 ohm and 2 ohm with the what? Parallel. They are in parallel. So if I will draw the diagram, it's gonna be look like this. This is 12 ohm. This is 2 ohm. 4 ohm. Okay. So if I will solve this for you guys, so 1 upon Rp is equals to 1 upon R1 plus 1 upon R2. So if I will solve it, so it will become 12 upon 7. So Rp, I'm getting 12 upon 7. But, but, we don't have to use, we don't have to use this. Okay, you know why? You know why? Because we have the formula P is equals to V square by R. Are you getting this? Now in the parallel, the voltage is same. I told you in the starting also. So it means that in 2 ohm resistor, what is the voltage?
4.
4 volt. And resistance is 2 ohm. So what we will get? 4 square by 2, which is 60 by 2. It means that it is 8. In the both the cases, the power is same.
So now we have to do comparison.
So comparison we did now. In the first case, what you are getting power?
8.
8 watt. In the second situation,
8.
8 watt. So you are getting the same.
Sir, if the second case we got 10 watt, then
10. So 10 watt means
10 watt power in the second case. Imagine.
imagine what? Say it again.
If in the second case we got power is 10 watt.
You got power as 10 watt.
Hmm.
So if you will get 10 watts, so it means that the parallel is getting more power.
The parallel getting more power. Okay.
Okay, did you understand, guys?
Yes.
This is one of the important questions. Please put a star mark. Did you understand, guys? Say yes or no.
Yes.
Okay. So with this end, we have completed this chapter. You guys please solve the rest question. We did 1, 2, 3, 4 questions. And rest you guys have to do it. Means out of 18, 14 questions. So I hope you have enjoyed the class. Till then, bye. Have a nice day. Signing off. Sayonara. Bye.